Yeah. So good evening, all of you, and welcome to the Statistical Analytics Department. And today is the doubt clearing session of our students. So, and also assignment discussion problems. It will be a mixture of that. So let's get started. Okay. So yep. So I will start. So we have posted the doubts. I have asked the students to post their doubts in the classroom, and Shoryangshi and Tishika have posted. Others have not posted, so I can't discuss others because that's the rule of the class. Um, but yeah, I heard there are a lot of problems in there, and mostly they are mathematical problems. So let's see what problems we have over here. Fine. So let's start with this. So let's start with this. So this is from Shuryansh's doubt. I will do alternately. Okay. So the question is from real analysis. Mostly people, the doubts are from real analysis. That's good actually. But I have plans to do doubts from also the assignments you give. Otherwise you will not be solving problems of the assignment. Okay, so it's not good. We should be solving problems of the assignment. That's really important. So you should be giving the doubts of the assignment also. Anyways, let's get started. So it's a function from 0 to 1, from 0 to 1 to 0 to infinity. It's a non-negative function from 0 to 1 closed interval, and f of t whole square is less than this equation, 1 plus twice integration 0 to 1 f of s ds for all t belongs to 0 to 1. Then the question is demanding that what we do with this, what is the behavior of this function f. Okay, the question is demanding what is the behavior of this function f. So how will you approach this problem, guys? Any ideas in your mind? Space. How will you approach this problem? Any ideas on how to approach this problem, guys? Suryansa, can you please share your thoughts that you have explored during this solving this problem?
Differentiating with respect to t,
Uh,
both sides.
Differentiating with respect to t both sides. Okay, but do you are you sure? So Suryansh is asking that differentiate with respect to. Why I'm writing this down because it's a common mistakes and misunderstandings people have about this stuff. Differentiate both sides. So and this inequality sign will remain the same, and this inequality sign will remain the same. So if ft is greater than gt, then f dash t is also greater than g dash t. Can you give a counter example to this? So we'll explore this together. So let's say f is a function, ft is greater than gt for all t. So is does f dash t greater than g dash t always, or is f dash t less than g dash t always? Tell me. So let's give an idea. I mean, it's okay. We all do mistakes and we all have misunderstandings. So uh, let's learn from that. So is this true, guys? Can you give an counter example to this? Of course, it's not true. So can you give a counter example? It's like telling that if
It's not true for the function whose range is between 0 to 1. Apart from that, it's true if fx and gx both are continuous. I mean, if the function is ranging between -1 to 1, then it's not true. Other than that, it's true for function if the function is continuous.
okay, so tell me one thing, Suryangse, that this tells about the relationship whether one function is greater than the other function. Okay, and this tells you about the relationship about the rate of change they're happening. So can you think of a function like this? Let's draw a function. One, so I will show one decreasing function and this is increasing and this is decreasing. Can you find one decreasing function, okay, which is greater than an increasing function? Can you tell me that? Can you give me an idea? A decreasing function derivative is always negative, and increasing function derivative is always positive. So show me, give me a decreasing function which is greater than an increasing function always. Show me diagrammatically, and then we will find. Always diagram is the first step, and then we will try to mathematically, logically formulate it. The question is this: show me a decreasing function which is greater than an increasing function. Right? Did you understand, all of you? Suryangsi, show me, give me an idea geometrically. Tell me what do you think? Like a decreasing function, like decreasing, an increasing function is increasing. Can you find? Okay, so you're telling it over a specific interval. Follow me. Okay, can you tell it over, like, let's take the range to be minus infinity to minus infinity. Okay, let's take the range to be minus infinity to minus infinity. But yeah, so actually Ptolemy's thing is correct. I think she told this type of function. She told, like, let's take 0 and 1. So this type of function, just if it's on 0 and 1, this are the two functions. Like this is the f of t, and sorry, this is the g of t. It's increasing, and this is the f of t. It's greater than or equal to this. But the derivative, you see, this is decreasing, less than 0 derivative, and this is greater than 0. So it's the remaining, it's not the same. So can you give it an interval minus infinity to infinity, not on 0 to 1, let's say? That's good. Ptolemy's question is good. Thing is good that she told, like, minus, that is true, totally. Can you give another example? On 0, minus infinity to plus infinity. Suryangsi, any ideas? It's okay, we can, like, I'm asking all of, since it's a doubt, I'm trying to make you do the problem. The question I'm asking this, that f is increasing and g is decreasing, okay, and still f is greater than or equal to g. Sorry, f is less than or equal to g. This is what I'm trying to find. On minus infinity to infinity, the domain. Okay, I mean, but you can understand, like, okay, so let's say I ask you to give a function which is decreasing and greater than 0, and which is decreasing and greater than 0, a function which is decreasing and greater than or equal to 0, and a function which is increasing and less than or equal to 0. Can you give such a function which is decreasing and greater than or equal to 0, Suryangsi?
Yeah, e to the power minus x.
Very good. So it's e to the power minus x. No, no, others don't reply, okay? So can you give an increasing function which is less than or equal to 0 and still increasing? It's very easy. Just like relate to this function. Somehow make it
Minus of
very good.
e to the power minus x.
Superb. Minus of e to the power minus x. So geometrically, if you draw stuff, it makes your life very, very easy, okay? So first step is human minds think geometrically, visually, and then try to mathematically formulate it. So this is the, like, steps you should follow as a human being. So that's the idea. Okay, perfect. So you have got this example now, right, to Suryanshi, that e to the minus of e to the power minus x ka derivative is always increasing greater than 0, and its derivative is always decreasing. So its derivative is decreased less than 0 and still it's increased, like these are greater than. You understood? So the sign may
Yeah.
change. Okay. Okay. This is very easy to get because 2x and x. This is very easy. 2x and x. This is very easy. But this is a bit trickier. So it's e to the power minus x and e to the power minus of e to the power minus x. So this is the idea. So draw geometrically. It can also happen that none of them can hold. Okay, so how do you get such a function? It's very easy. You first define f dash of t and g dash of t, any function, you whatever way we want to make them behave, and then integrate it, and you will get the final function f t greater than gt. Okay, and like there should be certain rules such as it's greater than 0, but greater than that. But yeah, so that's it. So this is the idea. Okay, so we cannot tell that by differentiating we will get this thing very clear. Okay, we cannot differentiate both sides to get something, but of course it's demanding differentiation in some sense. So how do you find like it's telling that ft whole square is less than something. Okay, it's asking you that ft whole square is less than this. So now tell me, like, it's asking now what is f of t. It's asking now what is f of t. So how do you do this? Any ideas? Any ideas, guys? Any ideas, guys? So see, and just option match, okay, but that is not what we are looking for. Okay, we should be evolved students who are good at problem solving. We don't take shortcuts. We take shortcuts in exam, and that is left for the last 2 3 months. But here now we are seeking knowledge, pure knowledge, and that's why we will do it every single step that is important. It may be long, but it is useful towards a long run. Okay. Okay. So f of t is equal to 1 plus t. So what? Why are options given? In exams, the options are given in exams to help you, to give you hint in which, like, step, like how will you proceed towards that. This is how options help you in exams. Okay. So options give you hints on how to proceed towards the problem. So now it's asking for f thing. So what is that thing? Now understand one thing, that f is non-negative. Okay, f is non-negative. ठीक है, f is non-negative. So the fact f is non-negative, that integration 0 to 2 fs ds, this is a function, let's say ft, this is always non-decreasing, just like cdf. Okay, since f is like a non-negative function, so like just it's just like cdf, so its ft is non-decreasing. So this is the maximum value that the ft can take, the integration can take. Okay, so think about in that sense, ft is the maximum value it can take. Also, do you know this result, that this idea that if f is a continuous function, then on a closed interval it always takes the extremum values. It's take a minimum value, it takes a maximum value. Do you know this result? It's called extreme value theorem. Extreme value theorem. I think I have revised this, I'm sure. So if f is continuous on a comma b closed, this closed is important, then there exists some c and d between this closed, such that f attains the maximum and minimum at c and d respectively. If the maximum is capital M and the minimum is small m, then f of c is m and f of d is small m. So they exist as c and d. Okay, that means what? You can clearly write f of x is less than equal to capital M for some m and less than equal to, like, for some c and m. Okay, you can clearly write that. So can you use this over here? Extreme value theorem, this idea. What can be the maximum thing? Yeah, tell me. Any ideas? Any ideas, guys? Tishika, Nikhil, Dev, Mansi, Shana, Paulami, Pratiksha, Proma, Rishabh, Shoikot, Sneha, Sriteja, Vasant. Any ideas? How will you approach this problem? Okay, so since the hint is given in your question, okay, so this is exactly the thing. When you don't have something, always try to take shorter examples, okay, and see what happens. So let's take ft is equal to 1 plus t. This is not option matching. We're trying to understand and prove it, okay. But since the hint is given, we are taking hint from it. So if you take ft is equal to 1 plus t, then what is this? Sorry, Suryangsi, bolo. What this will turn out to be? If you take this, yeah, tell me.
1 plus t
Whole square
whole square
less than.
is less than 1 plus 2
Mm-hmm.
integration 0 to 1
Uh-huh.
1 plus SDS.
Very good. So tell me what will be the right hand side? Tell me what will
One
be.
second.
Yeah, sure. It's 1 plus a square by 2, so it's 3 by 2.
3 by 2.
It's
3 by
4.
2, yeah. 4.
So 1 plus t whole square is less than 4, less than equal to 4, less than 4. Always here in this case. Tell me, it's very easy.
If t becomes 1, then this statement will be false.
Why?
It should be less than equal to. If t is 1, then LHS will turn to 4,
Very
and
good.
4 cannot be less than 4.
Superb. Superb. So this is not possible, right? Very good. So that's why we also try to see whether the problem is true or not. Now let's try to understand this. So this will also give you an idea whether this problem can be truly solvable in all the terms or just like it's asking for this options only. Okay. So options are giving you ways to think about it. Okay. So let's move ahead to this other three cases. So now how will you deal with the other three cases? Ft is less than 1 plus t by 2. How will you deal with the other three cases? So how will you deal? Ft is less than 1 plus t by 2. So what can you tell about this? Okay, understand this thing very carefully. If ft is less than gt and ft is always greater than equal to 0, okay, not all, like it doesn't matter, then of course you know the integration rule, the integration ft dt, okay, or on whatever, like let's say whatever is less than integration gt dt. Is it true? What do you think? Is this true always? Are you sure it's true? What do you think? This is true always? These are things you should be knowing. So tell me, is this true always or not? We can take previous example. Okay, which one example? No, understand this is over AB. Some interval that they defined. So tell me the example, Nikhil, what you want to mention, or which example you're talking about. I'm telling about this. This is different. If f dash x is greater than g dash x, then integration, then fx can be greater than gx. If something if something is true. If the initial portion are greater than each other, then of course it's true. Okay, so he's asking me to take this example that e to the power minus x and minus of e to the power minus x. Okay, so if you do integration 0 to 1, say 0 to 1, so tell me what are the integrations coming out to be? So e to the power minus x is greater than minus of e to the power minus x. So it's of course true that integration of this plus this is what? Integration of e to the power minus x plus e to the power minus x, that is twice e to the power minus x. It's not greater than 0, of course. Like, I mean, it's very easy to understand. See, tell this, understand this. If ft, if ht is greater than 0, you can easily understand that integration ht dt is also greater than 0, right? Because this is greater than 0, so individually we are adding up the small positive terms to it, so it will be greater than 0. So here ft gt minus ft is greater than 0, so integration ft minus gt is gt minus ft is also greater than 0, and we can now again like divide it. It's very easy, huh? It's true always over a certain, like over a certain interval. I mean, over a certain interval, I'm telling you, if it happens over a certain interval, maybe. Did you understand, guys? Yeah, it's very easy. So always have your basics cleared. Okay, that's why I'm focusing on your basics too much. So therefore, this is true. So now, can you use this over here? Now, can you use
What
this?
did you say there when you said that f dash t greater than g dash t if in the
No, no. I
initial
told
state?
this that ft is greater than g less than gt. Okay, then integration a to b is less than integration a to b gt.
No, not this integration one. In this right side, you were doing something differentiation. You said that if they
Oh,
in the initial stage.
initial. Okay, okay. The idea is that what can happen is that if the initial stage where both are like this is greater than this height, and of course it's increasing, more better increasing than this, then of course this will be greater than that. That's so it's like, let's say, let's take an example. Let's say f dash of x is equal to 1 in one case, and f dash of x is greater than equal to 2 in one case. So it's not true that f dash of x jiska 2 hai would be greater. Why? Because if f dash of x is equal to 1, it may look like this. Okay, if dash of x is equal to 2, it always doesn't mean that it will look like this. It's an assumption where it's starting from. It may also look like this when it's starting from this. So it depends upon where it's starting from. So if the initial portion is greater than 0, so the integration is also greater than 0 always. That's the idea. Like ft also greater than 0. That's what I told. Okay. So that's very important. This ft and gt is always greater than 0. Okay, and integration is also like that will of course happen. So that's the basic idea. So why I told this, because to connect differentiation and integration. Anyways, coming back to the problem. So now coming back to the problem, I discussed a lot of side comments which are important to understand the problem, and it takes time to understand in depth. So now understand this. So let's. So it's all these problems, all these statements are of one type only. Ft is greater than something, some function, whether this equation will hold or not. So that's the idea. So now equation will hold or not. Also, you have to understand option matching problem. Like you have no other choice to do option matching, or it's something else. So think about it. So maybe this is a problem. What it seems to me is that it's an option matching problem, because finding all such functions which satisfy this property may be a bit tedious. So option matching, like it's demanding that consider this case and then see whether this happens or not. That's demanding. Okay, so we have got the first one. Now let's go to the second one, because you understand this find a little bit tedious over here and it's not easy to be done. So ft is less than 1 plus t by 2. So if asking that ft is less than 1 plus t by 2 for all t, so its maximum is what? For all t, okay? So if, so okay, so let's find out this one. Yeah, 1 point like 5, of course, 3 by 2. So maximum can be 3 by 2. Okay, so now think about this integration. So ft is less than 1 plus t by 2. So we have to find out something about this integration. So integration 0 to 1 fs ds is less than what? Is less than 1 plus this, which is turns out to be 1 plus 1, 2. The maximum value of this is 2. So this maximum value is 5. Okay, but we have not proved whether this is always less than equal to this or not. We have not proved that. Anyways, let's get back to the next equation. So we are trying to understand what happens. So this by basic integration result. So if we take ft is greater than 1 plus t.
How did you write FSDS is less than 2, integration FSDS less than 2?
Oh, I just integrated it, and I just integrated over here just with the previous result. I hope I did the thing correctly. Oh, sorry. I'm so sorry. Yeah, I am sorry. So this is turning out to be 1 plus t square by 4. So it's 1 by 4. I'm sorry. It's 5 by 4. Now it's correct? Now it's correct?
Mm.
Yeah. Thank you. So it's 5 by 4. So now it lets us think that ft ka maximum value can be this t by 2, okay? So like it can be 3 by 2, which is greater than this. So can you think of a function like where it can happen? Now to think of a function. So let's see this. It's asking ft is less than 1 plus t, right? T by 2 for all t in 0 and 1. So we have got that ft whole square is less than 1 plus integration 0 to 1 f of s ds. Okay. Now understand this. We have got integration 0 to 1 ft is less than, or f of s ds, we have got it less than 5 by 4. Is it correct? 5 by 4 we have got? Yeah, 5 by 4, right? So sorry, there is a 2 over here. So let's see what is the maximum value that can happen over here. This is less than 7 by 2. Okay, which is what? It's around 3.5. And ft is this. So its maximum value can be less than 3 by 2. I'm just trying to understand the maximum value that can happen. Almost very close. Okay. So it can happen that since it's this, it can happen like this. Why I'm telling you this is that it can happen that it's, I will tell you why it can happen. So maximum value is 3 by 2. Okay. So that means here it's 9 by 4 and here it's 7 by 4. So which is better? This is 36, this is 7. So is it possible? I think personally may not be possible. Okay. So maximum value of this can be 9
When we
by
are
4.
comparing, we should compare the maximum value of left hand side to the minimum value of right hand side, no? Since it's less than sign.
You're right. We are comparing the maximum with the maximum. There's a reason behind it. The reason is that there can exist certain t, okay, which can exceed this. If I denote that function very carefully. So I'm just comparing the maximum value that are possible in both the cases. So here is the f of t whole square. This is the idea, okay? Understand this. Here is f of t. Okay, f of t square same. Its maximum value is this, let's say, or let's define it properly. So it's f of t whole square. Its maximum value is this, let's say. Now there is another number which we don't know. So we are trying to find the maximum value of that. It's told that always that will be less than this number. So if we can somehow find such a point, if we can somehow find such that the maximum is less than 7 by 2, which is actually happening. It's telling the maximum is always less than 7 by 2. This maximum. If we can somehow find that 9 by 4, which is actually less than 7 by greater than 7 by 2. This height is 9 by 4, this is 7 by 2. Then it can be done. I will show you how it can be done. Okay? But it can be done. So let's think about it, how it can be done. But let's check the other options first. I will tell you what is this going on. Okay, I will tell this first only. Understand this. That let's say ft is less than 1 plus t by 2. So it's 1 plus t by 2 minus some small quantity epsilon t, say. Some small number which epsilon t. Now we are integrating. So what happens? ft whole square is 1 plus t minus epsilon t whole square. उधर क्या है? उधर it's 1 plus twice integration 0 to 1 plus t by 2 minus epsilon t dt. ठीक है? We know this is less than 9 by 4 and we know this is less than 7 by 2. So what we have to find? We have to find such a point such that this becomes more than this. This value becomes more than this. That's the only m. That's our intuition from the geometry what tells. You have to find such a t such that this becomes more than this. So let's find out the integration now. It's 1 plus we already know this. This is turns out to be like this is what it turns out to be 7 by 2. Of course, came out minus integration twice integration 0 to 1 epsilon t dt. Okay, this is this function, and we have the upper one, which is 1 plus t minus. So we want to find at the maximum point 1 only. So it's 3 by 2 minus epsilon t whole square. Okay. So we want to find the maximum point only, let's say, where it's actually happening. Okay. We want this only. So can we design such an epsilon for which it can happen? Can we design such an epsilon? So let's find it out. So that's why in the exam hall, you will not do this calculation. You will do it from this understanding, okay? But this calculation details are important. So let's say, can we replace this epsilon t by a small, like let's say a small number, okay, a small constant. Let's say epsilon t is a constant. So it turns out to be 7 by 2 minus twice epsilon is less than 9 by 4 plus epsilon t whole square minus thrice epsilon t. Epsilon, let's. I'm just replacing epsilon by this. This turns out that epsilon square minus epsilon is greater than 9 by 7 by 2 minus this, which turns out to be, let's take this, plus 9 by 4 minus 7 by 2, which turns out to be, am I doing it correctly? Yes, I guess so. Okay, am I doing everything correctly? I did some mistake, I guess. Okay, this is actually greater than that. Okay, no, I did some mistake. I actually assumed 4 over here. So this is actually less than that. So it can actually happen. It's 18 and it's 28. So 7.2 is actually greater than that. Okay, this can happen. This can actually happen. Okay. So I was thinking, I was read this question, this I thought that is 7 by 4. Anyway, so here what you can do is that if it was 7 by 4, so you could have understood it's plus half, which you could have understood whether it's greater than 0 or not. You can find an epsilon for which is greater than 0. Okay, you could have find that. And let's say such an example will be, no, I mean just half itself. If you take epsilon is equal to half, that will just suffice. But you understood the idea. What I told, I thought that it was this. So what I'm doing is I'm comparing the maximum value with the minimum value, with the maximum of both, and trying to find a function. If it was 7 by 4, but it was not 7 by 4. I just did some miscalculation. So now we have to think whether this can happen or not. 9 by 4 is the maximum value that can take, and this is the maximum value this can take. Now you have to compare with the minimum value of that, whether it's a minimum value can happen or not. Okay, are you understanding the procedure? Did you understand this procedure, even if it was like wrong? I assume this which went by 4. Did you understand that or not, or is it confusing?
Sir, repeat the last part. I just got cut off.
Yeah, last part is that I read the question wrong. So it was, I assumed it's 7 by 4. That's why I was telling that 9 by 4 is actually greater than 7 by 4. So I'm comparing the maximums. In that case, if it's a 7 by 4, for epsilon, if you put it to be minus half, like just half, if you just put it to be 1 plus t minus by 2 minus half, here 1 plus t by 2 minus half, then it would have been that the maximum value of that would have been just this maximum value will be less than the maximum value of that at that extreme most point. So in that case, the solution will not happen. But understand this very carefully. One thing very carefully. Here, this is just a number. Okay. Here, this is just a number. So it's just a number. Okay, and it's a function. It's asking whether the function is less than or equal to that number or not. Okay. Yeah. Confusion. Confusing. Okay. Yeah, I know it's confusing. I know it's confusing. I know it's confusing because it's. I think it's from a math paper, right, Suryangsi? Is it from a math paper or a stat paper?
Yes, no math.
Yeah, I know that. Yeah, it's from a math paper. It's a GET math paper or something like that.
Jam math paper.
Huh? Jam last.
Jam.
Okay. Yeah, because it uses results that I stat don't use. Stat people like stat may it's not used. So extreme value theorem is not used in the paper, but it's fine. You should learn this in depth, and this requires some mathematical elegancy more. Anyway, so let's do this problem. It will take some time because it's maths and you have given this a doubt. Okay. If ft is less than 1 plus t by 2, let me think. The maximum it can get is 3 by 2. If 1 plus t by 2 is less than 2, if t is less than integration, wait, but I am not understanding that stuff. That if ft square is less than that, okay, so ft square we have got what? So yeah, so ft square we have got it's less than 2, right? So we have got ft square is less than 7 by 2, always in this case. If this is the case, then we have got ft square is less than 7 by 2. So is it true or not? That's my question. So the maximum it can take is ft less than 3 by 2. It can take that. So ft square is what? Is less than 9 by 4. Although it is less than 7 by 2, but we cannot tell. Oh, yes. Sorry. Yeah, you're right. Actually, we did before. Yep. So why I'm getting confused. Yeah, it's done actually. So we have already shown that ft is less than what? 7 by 2. All of you understood this? We have shown already ft is less than 7 by 2. We have shown this, right? You're right. Thanks, Dev Paddle. We have already shown ft is less than this, right? All of you got this? Suryansh, did you understand? We have got this.
Yeah.
So now, what is the inequality telling? The inequality is telling that whether this holds or not. And we also have understood that whether ft is this less than equal to that number or not. Okay. So we already know ft square now is less than 9 by 4. Why? Because ft can take 1 plus 1 by 2 maximum value, 3 by 2. So therefore ft square is less than 9 by 4. So is this true? Yes, it's true because it's less than 7 by 2. Again, understand. We have already done that. So again, understand what we are telling. We are telling that what the question is asking, demanding. Question is demanding that ft is less than some gt for all t. So what I'm showing is that if ft is less than gt, then ft is less than maximum of this. So let's say we are calling it m. Okay. And what is the extra condition we have? We have the condition that ft is less than this. We have the only condition that ft square, ft square is less than what? That 1 plus twice integration 0 to 1 fsds. We have this only condition. This must be true. And we have got that this is less than what? This term, okay, I have a bit of an issue over here. We should compare the minimum actually, not the maximum. That yeah. So actually, we have to compare the minimum, not the maximum. So this is what? This is This maximum value of this is what? The maximum value of this we have turned out to be 7 by 2. We have got from the condition that the maximum value of this turned out to be 7 by 2. And we know that ft is less than 3 by 2. So is ft square, ft whole square is less than always this quantity? We do not know actually. Because we know that this quantity is less than 7 by 2. Okay. And we know the ft square is less than 9 by 4. But we do not know the relationship between these two as of now. So this is not actually done. Okay. So we have to find the minimum of this, not the maximum of this. We have to find the minimum of this. As I think Tishika or someone was telling. Okay, so let's explore the other options. So we have not understood the connection between this one and this one. ft square, we have to find the minimum of this and we have to find the maximum of this, of course. Okay, we have to find. So aim, as someone was telling, we have to find the minimum value of this. And we have to find the maximum value of this. And then we have to compare these two from the given condition. We cannot find the maximum value. We have found the maximum value to be 3 by 4. And we have found out that this is less than 7 by 2. But we don't know the minimum of this. Okay. Of course, you know the minimum of this is always less than greater than equal to 1. Minimum is always greater than equal to 1. But you don't know whether it's true or not. So we cannot tell that. So if it's greater than less than equal to 1, then it's done. But it's not less than equal to 1 over here. So let's understand this. So let's understand the other cases. You understood why we cannot infer anything from this, guys? Do you understand why we cannot infer anything from this, guys? Suryansi, do you understand?
Not really. I mean, a bit of it I understood, not fully.
Okay. So is it the case for all of you? Okay. Let's understand this, what we're trying to do. This problem is, okay, let's understand what we're trying to do. We have ft whole square. We have to make this condition. This is a number. What number? This number. This is a number, just a number. It's an integration, so it's a number. So it's trying to give an upper bound to this ft. So from the given condition, so this quantity, we have two quantities, this and this. So we have to show that this का इसका minimum जो value possible है, it's always greater than इसका maximum जो value possible है. Otherwise you cannot find this. So इसका minimum possible value must be greater than the maximum possible value. Otherwise it will not happen, right? Did you understand now, Tishika? Sorry, Suryangsi.
Yes.
So now here from the previous example, we have got if maximum value is 9 by 4. But here we have not got the minimum value, we have got the maximum value. So we cannot compare maximum with maximum as someone was telling. But I was doing the problem in a different way. I took some numbers wrong. Yeah, we can use the result. But we don't have the minimum value, or do we? That's exactly what we're doing. When we did the integral, we found the upper bound. Okay, so let's go on to the other options, okay? Let's take this option. ft is greater than 1 by t, 1 plus t. If ft is greater than 1 plus t, it's the maximum. So if ft is greater than 1 plus t, So ft is always like the maximum value is always ft, f1 is always greater than 2. That is done. Okay, so the maximum value must be greater than always 2. We know that because f of 1 is always greater than 2. So maximum value is always greater than 2 in this case. Now let's come to this. 1 plus twice 0 to this. This is always greater than 1 plus 2. So this is greater than 2, so it's 4. It's 5. So it's coming out to be 5. The minimum value must be at least 5. Okay, I think I did some mistakes. Yes, I did some mistakes. So this turns out to be, sorry. So it's integration 0 to 1, 1 plus t. One plus SDS. So this turns out to be 1 plus twice 1 plus a square by 2. That is 1 by 2. Okay. So it turns out to be 4. A bit less bound. So the minimum value is turns out to be 4 over here. And the maximum value turns out to be greater than 2. So what to do in this case? You understood? The minimum value is turns out to be 4, the maximum value turns out to be greater than 2. So what can we do in this case? Can we find such a function such that, so I'm going to the crux of it, that the maximum value is always greater than 2. We know that. Yes, we can find, because there is no lower bound to this. We can make the function very large. We can make the function very large. Okay, we can make the function very large. So let's take an example over here. 1 plus t hai. So we'll take the maximum to be less than that. Okay, so we will take the maximum to be more than 5, more than 4. Can we find such a function like that? Can we find such a function like that? When, so also the question is that when is this minimum value occurring? So this is also not something that is turning out to be really interesting. Okay, we have a hunch that this may not happen. That the maximum value, like if you make ft is really greater than some number, now it will actually cross this 4 line. Okay, that's a hunch. So let's take the last option. This problem is a bit more involved than I expected. Or it can happen that I am not doing it the right way. It can happen that also. So ft is less than 1 plus t. So let's take this case. I think this will happen. You know why? Because I have a hunch that ft is equal to 1 plus t. This was not happening for just one case. T is equal to 1 ke liye. Otherwise it was happening. So I think if we take ft less than 1 plus t, I think this will happen. I feel. So if ft is less than 1 plus t, then ft value is what? 2, less than 2. And 1 plus twice integration 0 to 1, 1 plus SDS. It's turning out to be what? It's turning out to be again 4, I guess. Did I do some mistakes over here? Oh, I think it's ft is 2, it's 4 over here. Okay, I see. You should be telling this I am making this calculation mistake. That's why it's taking anyways. Similarly over here, it's 4 over here. So this is less than 4. Ft is less than 1 plus t. So ft का maximum value is 2. So ft square का maximum value is 4. Yes. Ft square का maximum value is 4. And 1 plus twice integration that fsds इसका maximum value is also less than 4. Ft square is less than 4. इसका maximum value is also less than 4. Okay. I'm getting confused actually. I don't know why. Okay, let's leave this problem. Okay, I think I'm not doing it the right way, or maybe I'm missing something really crucial, although I've done it correctly. Let's move on to a different problem. Okay, I will give it up to you after the class. Okay, anyway, so let's move on to the different problem. I will now move on to. So don't worry, students. I will share it to you after the class. Okay, I don't think it's really deeply involved problem either. So let's move on to a different problem. Otherwise, I think I will waste more time. So yeah, exactly this habit is also bad since I am like attached to a problem since it's my duty also. But in exam hall, if you're like seeing that the problem is being stretched a lot, so don't spend too much time. Okay, it's an exam strategy also. So let's move on to Shika's doubt. I will come to the next students' doubts also. So I will extend the class today's class bit because I think that I have sort of wasted a bit of time today doing this problem. So let's discuss this. So if alpha and beta are roots of the equation ax square plus, so what you have written, Tishika, limit x tends to
1 by alpha.
1 by
Alpha.
okay. Alpha plus beta are the roots. Alpha and beta are the roots. So cos of this c square cx square plus bx plus alpha by 1 minus. Okay. Oh, okay. Okay. So there is an result that if you see, it's nothing but it's called a reversible equation. It's a symmetric equation. So you see that if result number 1, if alpha is a root of ax square plus bx plus c is equal to 0, then 1 by alpha is a root of cx square plus bx plus a. Why? It's very easy to understand. If you just replace alpha is the root of this, so it means a alpha square plus b alpha plus c is equal to 0. Okay. Now, since alpha is non-equal, let's assume alpha is not equal to 0. Okay. If alpha is not equal to 0, then this will not happen. If alpha is not equal to 0, it's an assumption. And also, if alpha is equal to 0, this is not defined. So alpha is of course not equal to 0. So if you divide by alpha square, divide by alpha square. So you get what? A plus b into 1 by alpha plus c into 1 by alpha square is equal to 0. So what do you get? You get that 1 by alpha is the root of this equation. You see it now. If you put x is equal to 1 by alpha, you get this equation. Do you see it, guys? All of you understood it? Yeah, others? Did you understand? Okay. And good. So therefore, you can understand that cos of it will become 0 as x tends to alpha. So it's 0 by 0 format. So we have to differentiate. We have to differentiate. But you know this result that if limit x tends to a, f of x is equal to, let's say, capital A, then limit x tends to a, root of f of x is nothing but root of capital A. Okay, because it happens, why? Because of the composition of functions. So if you g of fx, the composition of the function, nothing more. Okay, limit goes inside the composition. Root is a continuous function, so it will go inside the composition. So it will go inside. Okay, that's it. So limit will go inside. So we will use this result, and therefore we will just need to find limit x tends to 1 by alpha root over 1 minus cos. So sorry, 1 minus cos alpha, sorry, a, sorry, cx square plus bx plus a by 2 into 1 minus alpha x whole square. Now can you do, Shika? I guess you can do it now. You just use L'Hopital rule.
Yes, sir.
Okay, do I need to discuss this further on? So
No,
cos x
sir.
का differentiation क्या होता है?
Yes, sir.
Cos x का differentiation क्या होता है?
Minus sin to 1 plus sin c x square bx plus a and then theta come differential.
So it will be twice c x plus b by
Yes.
here it will be 4 into 1 minus alpha x into minus alpha.
Minus
X. Okay, again it's becoming this, so you have to differentiate once again. Okay, it's a L'Hopital problem and there's nothing more to do it. Okay, Tishika,
yes, sir. I got.
all of you understood this? It's a good problem. You understood this, guys? Suryan, sir, did you understand this?
Yes.
Okay, so let's move ahead to the next problem. Let's take this problem of Suryansi. I don't know whether it will take on time. Mathematics wala takes a bit of time. That's true. So number of roots of this in the interval this is what? So the number of roots of this in the interval this, how can you do it? So one way to do it is that you can find out the derivatives first. Okay. So let's find the derivative. And f dash x, you know the derivative, it's nothing but e to the power t into t square minus, sorry, e to the power x by fundamental theorem of calculus into x square minus 3x minus 5 in the interval 0, 4. So let's find out the sign of this in 0, 4. So x square minus 3x minus 5. Let's again differentiate it, or just let's do law like Fridha Acharya. So 3 plus minus root over 9 plus 20. So root over 29 by 2. So it's 3 plus root over 29 is around root 5 plus something, 5 plus something. So it's वहाँ पर 4 plus something, and other root is 3 minus 5 by 2. So it's less than 0. It's less than minus 1. Minus 5 minus some epsilon. So it's minus 2 minus epsilon by 2, which is minus 1 minus something. So the root is, so if you draw it, minus 1 over here and 4 over here. So here is one root and here is one root. And therefore the function looks like this. the graph, it's like how the curve looks like this, and therefore it's all negative over here. So therefore, what happens in 0,4 region? All of you understood this 0,4 region is totally negative. Did you understand this?
So why it took -1?
Why it's
Why it took -1?
oh, because I was trying to find out the roots, trying to understand the roots. The root is not -1; it's less than -1, and it's less than greater than 4. Why? Because root 29 is what 5 plus some number, right? Some epsilon,
Yes. Okay. Got
So
it.
it's 8 plus some epsilon by 2 and 8 minus 2 minus epsilon by 2. So which is -1 minus epsilon by 2 and 4 plus epsilon by 2. Okay. All of you understood this, guys? Yeah.
Why we are only considering x square minus 3x minus 5 and not e to the power x?
That is always greater than 0. Fine. Since always less. So we are trying to find out that how it's behaving. That's it. So and this is always less than 0 here. So therefore what? It means that this function is decreasing in 0,2, 0,4 interval. That means it can have at most one root. Okay. That's why I always try to understand a function. The first step is to understand the derivative whenever it's root or anything like that. So at most it can have one root. Whether it's above the x-axis or below the x-axis or just cutting the x-axis once, you have to check. Why it is exactly one root? If it has two roots, somewhere in between it will be 0 by Rolle's theorem, f dash, which is not possible over here. So it will always be having one root. Did you understand, Suryankhi?
Yes.
Sure?
So we can use mean value theorem as well.
Yeah, but don't think about that, okay? I mean, we are complicating the whole stuff. It's like we are trying to find the derivative. So let's not use mean. Like, why will you use mean value theorem? Like, it's not required over here. I didn't get you. Like, why will you use mean value theorem, Tishika?
So I thought that it can be used.
No, I mean, see here what I have told. The idea is that you are trying to understand the derivatives, okay? The value of the derivatives. Then we have found out the value of the derivative is less than 0, so it's decreasing, and it must have at least one root, at most and one root, okay? Or 0 roots or one root. That we have to check. How we can check that? By comparing the values, by using the interval value theorem. Okay. How will you check that? We check since it's decreasing. So maximum value will be taken at 0 and the minimum value will be taken at 4. So let's check the maximum value at 0 is 0. The maximum value at 0 is 0. The minimum value must be, of course, negative. And it's open interval. 0. So it's always less than 0. Fx. Did you understand, guys? Did you understand? Or will I repeat once again? Suryansis, Riteja, Shoikot, Rishabh, Froma, Pratiksha, Paulami, Nikhil, Mansidev, Shayana. Did you understand? Sure. Let's understand this. Fx is decreasing. Did you understand this part? Tishika? Suryanshi? Fx is decreasing. Did you understand this part?
Yes, sir.
Okay. Now, therefore, the maximum value of fx will be taken where? If fx is decreasing in 0,4 interval. Bolo? Where will be the maximum value taken? 0. Right, Tishika?
Yes, sir.
So therefore, we are checking what the value of 0 is. Value of, by the way, it's open interval, so it's not taking the value even 0. So it's just open interval, and it's decreasing. So it must be always less than 0. It's not taking the value 0. So number of roots is 0. Did you understand? Did you understand? Shuryanshi, did you understand? Tishika, did you understand? Good. Okay, so let's move on to the next problem. Are you sure all of you understood this? Thank you. Thank you. Yeah. Okay, so let's move on to the different problem. Let's move on to Tishika's problem now. F is a differentiable function. So please give doubts, okay, guys? From next day onwards, I have given a doubt place so that I can clear your doubts too. Otherwise, you will feel that I am not given importance in class. That's it. And I don't want that. Say F is from 0 to 1 and is differentiable. And F dash X is less than or equal to 1. And F is differentiable. If F of 0 is equal to 0 and F of 1 is equal to 1, show that F of X is equal to X. Okay. That makes sense. So the idea is very simple. If F dash X is less than or equal to 1, you integrate it. The idea is this, okay? We are trying to find the maximum value of F dash X, F of X. So if you integrate it, F of X 0 to 1 dx is less than what? 1 by using the integration rule. It happens on integration, not on differentiation. So you get what? F of 1 minus F of 0 is less than or equal to 1. That's true, but let's replace now 1 by t. So you get F of t minus F of 0 is less than or equal to t. So you get what? F of t is always less than or equal to t. You get that. Okay? You always get that. But you have not used something more. You have not used the value of F of 1. You have not used the value of F of 1. So you have to integrate it now with respect to F of 1. So you do what? Instead of this, you take integration t to 1, F dash of X less than what? It will be t 1 minus t only. Okay? Integration 0 to t to 1, 1 minus t. So it will be what? Again, F of 1 minus F of t is less than or equal to 1 minus t. Now you get what? You get that F of 1 is equal to F of 1. So you get F of t is greater than or equal to t. And you get two different inequalities, which gives the following, that F of t is equal to t. See, I am solving the problems faster because a lot of time has been gone. So, did you understand, Tishika? Suryangsi, all of you understood this, guys?
Sir, why we took this T in between?
Why?
We took T.
Oh, because we want to, like, t is essentially the same as x. Because we want to have some idea about f of x. The only way to have some idea about f of x is to, like, from this f dash of x is doing integration and like moving out this differentiation. And we took t because we have to understand about f of x. By integration only, if we don't take t, then we cannot get f of t idea, na, Tishika?
Sir, if we had taken the limits from 0 to 1,
Yeah,
directly,
then we got f of 1 minus f of 0 is less than or equal to 1, which is itself true. It's not giving any extra information. But integration, if we just change the limit, we'll get much more information. Did you understand?
okay, sir. Yes.
That's why I did it. See, all of you understood this? All of you understood this? Good. Very good. Okay, lovely. Let's move on to the next problem. I'm doing very fast now because a lot of time has been gone. So pardon my speed. I don't know why I got stuck at this problem. I will check. Maybe I was trying too deep in it. This is the idea. Also, I gave an example of how to. Yeah, it's a nice problem. I have to also give an example of how to, like, solve the problem. So you see that I stuck over that problem and I was thinking about that problem too much. Okay, and it solved, like, it took us a lot of time. This exactly can happen also in your exam also. Okay, you're stuck over a single problem because you're emotionally attached to it. You like it. I was thinking about that problem, but see, if if I would have solved that problem, not solved that problem, and taken as a homework, and I will solve it later on, see, I could have solved more problems. So this is a real life example of what exactly happens, a simulation of what exactly happens in the exam hall also. So when you are stuck with a problem, leave it over there, move on to the next problem, because the other problems can be easier to tackle. Okay, maybe that's the hardest problem of the paper. It's a takeaway of today also, and like a real life simulation. Okay, let's coming back to this problem. Y is a twice differentiable function and y dash x is double. Okay, so y is just f of x. You can just think about that. Mathematicians have a right of way of writing like this. So y double dash x is equal to twice plus c to the power minus mod of x. X is belongs to real numbers. And y of 0 is equal to -1, and y dash of 0 is equal to 0. Good, because y double dash is given. She's asking about this. So therefore, it's mod of x. So you have to, whenever it's a function is given over here like this, always simplest form possible. So you have to change it, or like change this into a much more easier handling form. And that is what? It's twice plus e to the power minus x if x is greater than 0. And it's twice plus e to the power x if x is less than 0. Right? Very simple, guys. Very simple. Just very simple. Why? Because we will do integration after all. Without doing integration, we cannot go ahead to the cases of y dash and y, which is required. So therefore, we'll do the integration now. After doing the integration, what do we get? We have got that y double dash of x is equal to 1, sorry, 2 plus e to the power minus x is x is greater than 0, and 2 plus e to the power x is less than 0.
At x is equal to 0, the value should be 2. That should also be
Yeah,
included.
so sorry, guys. Thank you so much. Who was this? Who was this?
Suryanshi.
Yeah, thank you, Suryanshi, so much. Yeah, you're right. These things matter. So yeah, and actually it's actually what you can do is that instead of doing this, because it will make your integration harder, like look harder, so you just do less than equal to that. So y double dash y dash of x will therefore what? Will therefore see y dash of 0 is given over here. Understand this very carefully. Y dash of 0 is given over here. That's a good thing. Why? Because now you can actually take integration 0 to, so now what you will do is that you have given y dash of 0. So if you do y double dash of x integration 0 to t dt, that will give y dash of t minus y dash of 0. That's exactly what you want. That's exactly what you want, because this is equal to y dash of t. So you want y dash of t. So therefore you do what? You do this integration. So you do integration 0 to x 2 to the power e this x is greater than 0 के लिए, and here it's integration x to 0 minus I दे दिया 2 plus e to the power x dx, x is less than 0. So let's integrate this. If you integrate this, you will get, oh, I am very bad with integration. Can you do the integration for me, guys? Can you do the integration for me? You see, we are trying to connect y dash and y by doing integration, okay? And in fact, I think that's also the first thing we should do in the first problem, but I was somehow like,
Yes, we have taken the minus sign because,
oh, minus sign because it should have been 0 to x, now 0 to,
yes,
yeah. I mean, okay, why there's a mathematical mistake over this will be dt 0 to x, but x is negative over here. So better way to do is x to 0. No? It's negative over here. That doesn't mean like f of b minus f of I is b is greater than a. Okay, that only makes sense. So integration f of t dt, the fundamental theorem of calculus says that if b is greater than a, it's telling that if b is greater than a, then only we can write fb minus fa. So that's why we are converting this. Otherwise, we cannot apply fundamental theorem of algebra, calculus. We cannot apply that. So 0 must be greater than x. Otherwise, we cannot apply that. No? But yeah, actually no. You're right. We can apply that. Yeah, I mean it can also happen like 0 to x also over here. Same thing. Doesn't matter. We can apply that actually also. It becomes negative of that. It's totally fine. So if you don't want, you just do it like this. Leave it like that. No worries. 0 to x. So do the integration for me, guys, please. Do the integration for me.
Means if we write x to 0, then we will be not writing minus. And if we write this one, we have to write negative.
No. If you have write x to 0, you have to write minus. If you write this one, it's not negative. It's like we have not write minus. Like integration a to b fx dx is same as minus of integration b to a fx dx, and there is a result like this. If we change the sign, it becomes minus, right? Why? Because this dx is usually in positive format. So if you take minus dx, that's only it happens. Don't you know this result, Paulami? Like in school?
Yes, but yeah, I know. But here x is smaller than 0 now. So it is in the form b to a. Now it is in the form b means
Yeah, it's totally fine.
reverse one.
So here, what is this? This is f of b minus f of a. And here what is this? It's minus of f of a minus f of b, which is totally fine. Okay? It's totally fine. It's the same thing I have written. It's yeah. I mean, this is not to be confused. Is it confusing? Like, I don't know, Polemy. Is it confusing enough? Okay. Anyway, so this will be 0 to x. Please do me the calculation, guys. Did you do the calculation? Time is going away.
First one will be 2x
Yeah.
minus e to the power minus x
Yeah.
plus 1.
Good. Next one.
And e to the power x
Yeah.
plus 2x minus 1.
Very good. Thank you. Okay, this will be greater than 0. Good. So we have got this. So can you repeat it once again? Y dash x we have got.
2x minus e to the power minus x plus 1 and 2x minus 1.
Good. Now you again know what to do. Y dash of 0, y of 0 is given over here. So again you have to integrate it, right? So integrate it again on 0. So yx is nothing but again 0 to x 2t minus e to the power minus t plus 1 dt if x is less than 0, and 0 to x 2t minus e to the power t plus 2t minus 1 dt if x is less. So you will now find another function now. You understood now, Suryangsi? So we'll find out now. Now, after finding out that, you have to check these conditions. After finding that, you have to check these conditions. What really happens? But something interesting will happen over here. Let's try to understand this. What like with how this behaves. Okay, so the conditions given over here are there exists an x naught, so that y of x naught is greater than or equal to yx for all x. That means it's asking what? That there exists a maximum. It exists a maximum. Does there exist a maximum? Let's check that. So is any of them equal to 0? You have to check that if any of them is equal to 0 or not. Is any of them equal to 0 or not? Check the maximum, whether it exists or not. C to the power x is equal to minus 2x1. So this is a mathematics. I think it's all of them are from IIT JAM Math, no?
Yes.
Okay, so you have to draw this curve now to find out for x less than or equal to 0. C to the power x plus 2x minus 1 is equal to 0. So you have to do this 1 minus 2x. How does this 1 minus 2x function looks like? C to the power x looks like this, and 1 minus 2x looks like y by 2. 1, 2. This. So there exists a point where it cuts. Okay. Now understand over here that both of them are positive. This is positive and this is a positive number. So this is a positive number. So therefore, if there exists a point where they cut, okay, why I drew like this? E to the power 0 is 0, 1. Okay, the height is 1. And 1 minus 2x. If you put x is equal to 0, okay, I think I did some mistake. Yes, I did some mistake in the drawing. So it is a e to the power x. And 1 minus 2x looks like this. Function like this. So it's 0, 1. C to the power x. At x is equal to 0, it's 1. And this is also x is equal to 0, it's 1. And it's half over here at y. Like at y is equal to 0, it will be half. So this is the line. You can use the line intercept form to find this. And therefore it meets at 1. Okay, so f dash x is equal to 0 at 1. Y dash is 1 is 0. Let's find out this now. Let's draw this diagram now. Same type. You understood this diagram, guys? See, this is a math paper. You have to do more math. Can't help. You understood the diagram here, guys? Why y dash is 1 equal to 0? Huh? Yes, others? Suryank, did you understand? It's your problem. Tishika, Sriteja, Shoikot, Rishav, Proma, Pratiksha, Paulami, Nikhil, Mansi, Dev, Shaina. Did you understand? Of 1 is equal to 0. Suryank, did you understand? Good. So let's find out the other one. But this will not happen. Why? This will not happen. Oh, it will happen. Just give me a time. Yes. F dash of 0, not 1. F dash of 0 is equal to 0. Okay. So it happens f dash of 0 is equal to 0, not 1. The value is 1 at that point. Let's consider this. 2x minus e to the power minus x plus 1 is equal to 0. So it's turning out e to the power minus x is equal to 2x plus 1. So let's draw it. E to the power minus x looks like this. And 2x plus 1 looks like this. X equals 0, it's 1. So you understand that again the value is 1 and 0. and it can happen. It's continuous function. So at x equal to 0, it must be 1. So there is only one point f the y where y dash x is equal to 0, y dash of 0 is equal to 0. Therefore, there is only one point, and at that point is what? Y double dash is always positive. So it's a minimum, not a maximum. Did you understand this, guys? It's a minimum, not a maximum, because y double dash is always greater than 0. So therefore, wherever y dash x is equal to 0, it will always be the minimum. Did you understand this, Suryangsi, Tishika, all of you? Yeah? Good. Now let's understand this. Y is equal to 0. Exactly one root. Kitna root hoga? So it's asking how many roots does y has? Okay, this is a bit challenging in the sense. Not actually challenging. Okay. So you can understand that 2x plus 1 and e to the power minus x. So you can understand 2x plus 1 is greater than e to the power minus x for x greater than 0. That means 2x plus 1 minus e to the power minus x is greater than 0 for x greater than 0. So therefore, this is greater than 0 for x greater than 0. Let's consider this now. E to the power x minus of 1 minus 2x. You can easily understand that for x less than 0, 1 minus 2x is more than e to the power x. So therefore, this is less than 0. And you can understand, therefore, what you have. You have that therefore you have this at x equals 0, you have it's increasing and then it's decreasing. Here you have the y dash x is greater than 0, and here you have y dash x is less than 0. So what do you have to check? Sorry, I have done something wrong. X less than equal to 0 के लिए it's less than 0, y dash x less than 0, x less than 0 के लिए, x less than equal to 0 के लिए, and x greater than 0 के लिए y dash x is what? Is greater than 0. That exactly we have got, and here it's exactly equal to 0. Just check the minimum, therefore what the minimum happens. This is how the graph looks like. See, yeah, so that's the idea. When you know the f dash x, you can actually draw it. So you have to understand, we can understand more about the roots, okay? We can understand more of the roots. As you can understand, there is only one thing, Suryangsi. From the y dash the behavior, from where it's positive and negative, you can figure out where it's increasing and where it's decreasing. Where it's positive, it's increasing, then it's decreasing, it's decreasing. Increasing, decreasing. This is exactly you can find it out. And here you have found out that y dash x less than 0 means it's decreasing over here and then increasing over here. And then you have to find out about the roots. That means you have to find out where the minimum can happen. Where the minimum can happen. So let's see the minimum. Y of 0 therefore is what? Y of 0 you have to find out, therefore. Y of 0, not find out. It's equal to minus 1. So what we have got? The minimum is minus 1. So the graph lies like this, minus 1. So that means what? There are exactly two roots. All of you understood this? So you can see from the f dash of x, you can, from the value, positive or negative value of the f dash of x, we can find out how it behaves. It's increasing, decreasing, increasing. In the curve, how it's the whole function is curving out.
So I'm asking about f double dash x.
From f double dash x, we cannot find anything. From f double dash x, we can only find out whether it's a minima or maxima. Okay, that's why I found out first f dash of x. From f double dash of x, you can find out if somewhere its f dash x is 0. We can find out whether it's a minima or maximum. That's only we can find it out. Suryangsi. Okay. You understood? Suryanshi? All of you understood that here it will be exactly having two roots, guys?
Yes.
All of you understood you have exactly having two roots over here? Did you understand? Please say yes or no. Good. We have a lot of problems done today. Okay, let's do the last problem of today. It's a linear algebra problem. Let's do a linear algebra problem. It's Tishika's doubt. So Tishika, so whatever doubt has left, and Suryanshi, whatever doubt is left, you again upload it in the next week's doubt solving. Okay, I will upload it. I will discuss that. Oh, what will I repeat, Nikhil? Tell me.
Yeah, the two roots part, that's one.
The two roots part. So we have understood that a curve is decreasing, attaining a minimum, and then increasing, shooting up. So therefore, the only way we can understand the roots is that therefore the function can have how many roots? Exactly two roots or zero roots, right? Nothing in between. If it once come below zero, it has to again come over zero. So it will exactly have two roots or zero roots. It will only have zero roots if the minimum is greater than zero. It will only have two roots if the minimum is less than zero. It has zero roots if minimum is greater than zero. If it's two roots, only if its minimum is less than zero. That's the idea. Did you understand? Okay. So let's do this linear algebra problem. Like the last slide also. Find the basis of the vectors. Suryanshi, I hope you're understanding your doubts.
Yes, yes.
Find a basis for the, it's all about, drawing functions. Okay, it's all about drawing functions. As I told you, as you didn't have to find out fx. Okay, didn't have to find out fx. Without doing that, just with finding y f dash of x, we can do this problem. Anyways, find the basis for the vector space R cube that contains the two vectors this. Okay, so you have the basis this minus 1 3. Okay, so this two basis. So Tishika, tell me, using this two basis, what you can find out? You can find out a plane, right? Form a plane, right? Excuse me. Right? You can find out two-dimensional subspace of the whole R cube. Tishika, please unmute yourself. Oh, Tishika is not here. Okay. Anyways, so I will just discuss this problem. So just give me a minute. Okay, so using two vectors, we can find a plane. So therefore, do you like, if you take any other vector that is not in this plane and you consider this, that will be another vector and the other basis. Like if you consider this, take a vector which is not in this plane, okay, outside this plane, and consider this into vectors into the basis set. That will be a vector that will be making the basis of the entire cube. Why? Because if you consider this vector, this will be linearly independent, and this is the maximum linear independent set that you can have, right? Maximum, like this is the minimal spanning set and the maximum like linear independent set, which is the basis. Okay, so therefore you have a basis over here. So let's find out a line, a vector which cannot be generated by these two vectors, and it's very easy to find. It's very easy to find. How do you find it? How do you find a vector that cannot be generated like by this? Cross product? Yes. So you find a vector which is perpendicular to this. How do you find that? How do you find cross product, guys? But I'm like, let's talk about a general case scenario. Like, how will you? There are two vectors, v vector and w vector. How can you find a vector that is not here in this plane? In any dimension, okay? Cross product happens only in no, wait. Cross product happens only in 3 dimensions. The I cube and that stuff. Then it can be done in 8 dimension using quaternions. There's a theory behind that. Okay, but what will happen in this case? In general, two cases. So there's two vectors. You have to find a vector that is not in the spanning set of that two vectors. How can you find that vector? Any ideas? How can you find that vector? You have two vectors. You have to find another vector. The goal is this: two vectors via v and w are there. You have to find another vector u which doesn't lie to the spanning set of VW and this. How do you find that vector? Any algorithm to find that vector, guys? Let's say it's inner product. I mean, you can do all the inner product stuff. Like you can calculate distance and angle, everything. Everything. Any general ideas? It's a very interesting problem. Determinant is there to find it. Of course, determinant is there to find it. You're right. But let's do the general problem. V and W are there. How can you find a vector which is u, which is not in the spanning set of V and W? Tell me, it's a very easy problem. So let's understand this. Let's find out a vector which is perpendicular to this, both the vectors. So u dot v is 0 and u dot w is 0, right? Dot product is 0. That means they are perpendicular, right? So that is all. They have to solve these two equations. That's it. We have to solve these two equations. Find a solution to this equation. That's it. Okay. How do you find a special solution to this equation? Very easy. Just put 0, 0, 0 everywhere and delete variables. Let's understand this over here. So to find A, B, C such that dot product of A times 1, 0 is equal to 0 and dot product of B this times the other one. That means you have to find this ABC vector which is perpendicular to both of this. So you get what? A plus twice B plus C is equal to 0. Sorry, A plus twice B is equal to 0. And A plus thrice B plus C is equal to 0. We have got these two equations and you have to find out what? We have to find out one such ABC non-trivial is A, not A is equal to B is equal to C. So understand, if you put A is equal to A, if you put C is equal to 0, you will get that A is equal to B is equal to 0. A is equal to B is equal to C is equal to 0. Okay, so you cannot put C is equal to 0 over here. Okay, we also cannot put A is equal to 0 over here. Okay, so let's put A is equal to 1 over here. Or let's say minus 2. Then B will be turning out to be 1. And if A is equal to minus 2 and B is turning out to be 1, we get C is equal to minus 1. We got that. All of you understood this simple algorithm, guys. All of you understood this simple algorithm. How to find two vectors that is perpendicular to, how to find a vector which is perpendicular to two given vectors. That's the question. What do you do? You do two dot products that will give rise to two equations with, let's say, n variables. Okay, 0, 0, 0 is a very trivial solution. We have to find another non-trivial solution. So you try to put out conditions on how to find that. Okay, you try to put out conditions on how to find that. Okay, did you understand, guys? Okay, all of you. Okay, so I will be ending the class over here, guys, and we will be I will be sending you the solutions to Suryansi of that problem to all of you. And yeah, so I think I need to get through the other problems, and you can upload the problems that were not done in the class. Okay, so I think 34, 25, and 28 is not done for Suryangsi, and 1, 2, 3. Okay, there's another question similarly for this, so you can do it, guys. So do this problem out as a homework just right now. I have given the logic of how to do it. Just do it right now and send the solution in the group. See the same problem I've given. Check the WhatsApp group. Okay, bye bye, guys, and a very good night to you. Bye bye.